Well, hello again. Fancy meeting you here. Today we're going to do some notes on prime factorization. And you might be thinking, we already took notes on prime numbers, Miss Pepley. That we did, but we need to be specific on prime factorization. Okay, so only thing we're going to take notes on. Dun, da, da, dun, 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 dun. I cut out my prime factorization card. I'm using a glue stick. Ooh, I left the cap off for too long. It's starting to dry out. Yikes. Oops. Cover that stick up. And I'm going to put my prime factorization card on top. I'm also going to title my page Prime Factorization. Okay, so quick recap because you have already worked and learned all about prime factorization. So prime factorization is basically the ability to take any number and break that number apart using its factors. But instead of just finding the factors of that number, you need to keep going through the factorization process until the only numbers you have left are prime numbers. And if you suddenly forgot what a prime number is, you can always go back and check. It's a number that only the only factors in a prime number will have is one in itself. Okay, so a prime number is a number that I can't break down and divide up into whole numbers. All right, so prime factorization is a process of breaking down a larger number to end up with prime numbers. Okay, so I want to just write some examples so that it kind of sticks into our brains better than it already is, because you guys have been doing great with prime factorization. So let's give a couple examples. Okay, I'm going to go with the number, let's do 30. Okay, so I'm making almost like a tree, and I'm breaking my number apart. So I have a couple options, right? I know my factors of 30 are 1 times 30. Well, that obviously doesn't get me very far because I'm going to have to break down that 30 again. I have 2 times 15. I have 3 times 10. And I have 5 times 6. There are no other factor pairs that will multiply together to get me 30. So, what shall I go with? It really doesn't matter because I'm going to get the same answer any way I go. And to prove it to you, I'll give you 2 examples. Let's do 3 times 10 and 5 times 6. Okay, so right away I look at these numbers. I look at 3. Well, I can't break 3 up. It is in its lowest form, and so that is considered a prime number. So that I've already have one of my prime factors for 30. Now 10, I know I can break down into factor pairs because it is an even number. It's not 2, and I'm going to go 2 times 5. My only other option is 1 times 10, and like before, you need to break down to get to your prime numbers. So 2 is my only even number that's prime because it is so small that the only factor pairs it has are 1 times 2. 5 is also a prime number because I cannot divide 5 evenly by any whole number. So the prime factorization of 30 is, I always start with my smallest number, 2 times 3 times 5. Okay, now we're going to get over to here, and we're going to do the same process using our factors of 5 times 6. So right away I know that I just did over here. 5 is a prime number. I cannot break it down anymore. 6, on the other hand, I can break down, and I know that 2 times 3 is 6. Okay, well, here I go again. It's that 2, and it's prime, and I know that 3 also is prime, and I cannot divide it by anything but itself. So here, once again, going with the lowest number, 2 times 3 times 5. So you can see it doesn't matter what factor pairs you pick for prime factorization, you will always get the same answer. I hope that helps make sense and just kind of refresh how we do the process of prime factorization. I know you had a longer video yesterday, so I don't want to sit here and just chat at you all the time because that's easy for me to do. Okay, friends, you are rocking it in math. I am very proud of you. Keep up the good work, and remember to do your facts because you have to turn them in the next pickup. Okay, so take time maybe every day to do some math facts. They are the ABCs and the foundation of mathematics, and especially important now that we're in chapter 2, multiplication. Bye.